You'll be very happy to hear that Miss A thought this joke was absolutely hilarious.
Did not.
I think it's hilarious. So we're moving on to multiplying multi-digit numbers. With the partial products method, there are two algorithms here, and there are videos for each. I think they're both incredibly effective, but it just depends on where you are in terms of comfortability. I think partial products is easier to explain, but it's a little bit slower. So I like starting with this and then moving to the more standard algorithm later. So as we look at this problem, 34 times 6, it's really important once again to identify that the number 34 is made of 3 tens and 4 ones. So as we work through the partial products method, what I like to do is, instead of thinking of it as just the number 34, splitting it up into two pieces. So when I have the number 6 down here and I want to multiply, I actually want to multiply times each of these numbers. So what I'm going to do for this problem is I'm going to start with the number 6, and I'm going to multiply times the ones place in the top problem. So I'm going to do 6 times 4. And remembering that in middle school for multiplication we use the dot instead of the x. Now 6 times 4 gives me an answer of 24. I want to make sure that I line it up in the problem because if I end up getting my tens place mixed up, it makes the end of the problem very difficult. So now that I've done 6 times 4, this number's done. And now I want to do 6 times the next number, which here is not 3, but 30. So 6 times 30 gives me 180 as the answer, or if you did 6 times 3 tens, would give you 18 tens as well. Now that we've multiplied the 6 times every number in the top, we are actually done with the multiplication of this problem, and we just simply have to add the products that we found before. Just like we did in the last video, 4 plus 0 gives us 4 ones, 20 plus 80 gives us 100, and 100 plus 100 gives us 200. Therefore, 34 times 6 gives us an answer of 204. Moving to a problem that's a little bit bigger, but actually not that much more difficult, keeps the same process. Since the second number only has a ones place, we are going to multiply the 1 times each of the top numbers, once again keeping their place values in mind. 4 times 1 is our first step, which gives us simply 4 or 4 ones. Then we do 4 times 20, which gives us an answer of 80, or 8 tens. And then our last one is 4 times 600, which gives us 24 hundreds, or 2,400. Now that the 4 has been multiplied times every digit in the top number, we can simply add together what we got, which is 2,484. Look at that. I'm actually getting better at drawing these straight lines. So now we have a 2-digit times a 2-digit number, which gets a little bit trickier in the middle of the problem, but the rest of the process will stay the same. That's one of the nice things about partial products. I still want to start in the ones place of the bottom number, which here is a 3. So I'm going to take that 3 times each of the top numbers. So I do 3 times 3, which gives me an answer of 9. Whoops, that wasn't great. Then I do 3 times 70, which gives me an answer of 21 tens, or 210. Now that we've done everything with the 3, normally we'd be done with the problem, but this time we have a second digit in the problem, which here is a 20. So what I'm going to do is the same process. I'm going to take my 20 times each of these top numbers. So then I just add 2 more steps down here on the bottom. So I'm going to do 20 times 3, which gives me 60. And actually, I'm going to change the color here just to make this a little bit easier to follow. So that was 20 times 3, which gave me 60, I said. And then I do 20 times 70, which is going to give me 14 hundredths, or 1,400. This is one of those times when we got to be really good at multiplying with numbers that end in 0. It makes this whole process a lot easier. Now I simply add everything that I've done. So I add my ones column, I get 9 ones. I add my tens column, and I get 7 tens. I add my hundreds column, and I get 6 hundredths. And I add my thousands column, and I get 1,000. So my answer here of 73 times 23 is equal to 1,679. Seems like a tough problem, but once you work it out, actually not that bad at all. So now we're going to move on to our last problem, which is about as difficult as I would expect a level 3 6th grader to get. So I'm going to once again start in my ones column of my bottom number, which is a 7. So I'm going to do 7 times 2, and I'm going to show you how I speed up this process a little bit. I'm going to do 7 times 40, and then 7 times 400. So I do all of the setup right away for this first number. So 7 times 2 is 14. 7 times 40 is 280. And 7 times 400 is going to be 2,800. Mrs. A is happy that I didn't say 2,800. It's 2,800. So now as I move on to the next number, which here is an 80, I'm going to set up the process just like I did before. I'm going to do all of it at once. Now you don't have to, but it's the way that I like to do it. So I do 80 times 2, 80 times 40, and 80 times 400. Okay, so here I get 80 times 2 is 160. 80 times 40 is going to be 3,200. And 80 times 400 is going to be 32,000. Now, I ended up finding a way to run out of room in this problem, and I actually don't know how to slide down, so I'm going to have to move everything up a little bit. Let me see if I can remember how to do that. There we go. So I'm going to take the whole problem out of the top, and I'm going to move this up as well. So I add my ones column, I get 4 ones. My tens column, I have 9 tens, 15 tens. So I have my hundreds column, I have 10, 11, 12, 13, 14, 14 hundredths. In my thousands column, I get 3, 6, 8 thousands. And here I have 3 in my 10 thousands column. So my answer is 38,454, which is, like I said, about as difficult as these problems can get. Now, what's important to remember here is that the partial products method is really effective when we're looking at problems like 34 times 6 and being able to understand how we work through the problem. And it doesn't take much longer than the standard algorithm. However, when we get down to a problem like 442 times 87, the partial products method actually takes substantially longer than what we had been doing before, and we have to keep that in mind as if we're deciding what we're working on. So, as always, if you have any questions, make sure you let me know. If you do not score a 3 out of 4 or above, make sure you do the video retake.